Good day, viewers. We are going to start or rather continue from our part 1, and we will start what we have already uploaded in part 1, and that continuation will be here. So with that continuation, what we are going to do it here is that we have finished this particular problem. In this particular problem, it was given AB is parallel to CD. So this is given. Please note this. This is given. This is given. Okay, so since these two are given and we have taken BD is a transversal and we have said that angle 2 is equal to angle 5 because they are alternate opposite angles, which I have not written in previous one, but I thought that you would be able to pick up. But I want to introduce something else. That's why I have started from here. So join BD. This should come before coming to this transversal, this one. So I should have written join BD as a diagonal. Now, first one, I have started to prove that these two triangles, I have missed here a triangle sign, so I am now put it in here. Triangle ABD should be to prove is congruent to this thing. And again, BD is the transversal, so here, similarly here also, this is alternate opposite angles. Okay, so this is to be said. And why these are? Because these opposite angles, it is given, this is given, opposite angle, this is given, and BD is common, so this is congruent to this, and AB is equal to CD, this would be CPCT. CPCT, corresponding part of congruent triangles. This I have not written before, so please check this. This should be equal to CPCT. On that basis of CPCT, what I have done, I have come here and I have proven here that AB is not only parallel, but they are also equal. So pair of opposite angles, they are equal. Similarly, pair of these opposite angles are equal. Now, what is this congruent further signifies? This further signifies that 1 and triangle 2, they are totally equal, which means that BD divides the quadrilateral. I will write quadrilateral like this. Quadrilateral ABCD in two equal triangles. What does that further means? What does that further means? This further means that if I can find area of any one of these triangles, say let us say this triangle, then only I have to multiply it by 2. I wanted to point this one out today so that you will see a figure, a quadrilateral, and see which triangle you can find the area. So divided it according to that, and then you should be able to find the areas of the total quadrilateral. It is not only BD, you can also join this particular diagonal. This particular diagonal, that means this is also another diagonal, that is AC, is also another diagonal. This also divided. Also you can use this in order to prove all these points that triangular. So as BD divides into two equal parts, similarly AC divides into two equal parts. So this is what the congruency tells you all about. Another thing which is we have ultimately proven, we have proven that BD is the angles, opposite angles are equal. Okay, we have proven that angle B is equal to angle D. Similarly, we have also proven that angle A is equal to angle C. Now from here, we will go on. I will keep this triangle as this quadrilateral as it is, and then I will develop certain further things. In our earlier previous one, we have just proven that opposite angles, that is angle A is equal to angle C, and opposite angle and angle B is equal to angle D. Now the next one is the reverse that we are going to prove. That is, we will say this we have proven, this we proved. We proved. Now what we are going to do the next one or the next theorem is that this would be given. So given is angle A is equal to angle C, angle DB is equal to angle D. So what we have to prove? We have to prove that AB, opposite pair of opposite sides, AB is parallel to CD, and AD is parallel to BC. Okay, yes. So this is practically conversed. We proved this. Now this is given, and you have to prove this. And when we proved this, this was given. This was given. Given what? Given was AB is parallel to CD and AD is parallel to BC. This was given. This was given. And now this is given. So this we have already proved. Now this is given. How do we do it? So again, interesting, we will consider BD the diagonal because this is convenient. So take the diagonal BD. Okay. Now what we will do, we already know that angle A plus angle B plus angle C plus angle D is equal to 360. We had already proven. We have already proven this. Okay, this is given. Now look at this. I will concentrate on the lower one. So I will keep D. So if I keep D, so I will say this B will change to D. Okay, I will keep C. So I will say this A changes to C. Okay, because they are equal. So I can say angle C plus, in place of B I will write angle D, plus angle C plus angle D is equal to 360. Why? Why? Because angle A is equal to angle C and angle B equal to angle D. This is given. This is given. So if I from here, if I start using this side of the board, then it will be twice angle C plus twice angle D is equal to 360. Right? No problem? Okay. Therefore, from here I can go to angle C plus angle D is equal to 180. Now recall what we have studied before. We have said that if you have two parallel lines, and if a transversal cuts it, and if you have these two consecutive angles, this A and B, these are called consecutive angles. Consecutive angles, or this is also called supplementary angles. Triangles. Then their sum. Then their sum will be equal to 180 degrees. Okay? Now look at, let us convert this one. Let us say these two, we'll draw it in a different way. Let us say AD and this thing, and let us say CD cuts it. Okay? So this is AB and this is BC. No, this is AB and this is BD, and then these two will be supplementary angles. So angle C and angle D, and so here we will take this extension. Let us call it P and Q. So let us call it P and Q. There is nothing but CD. So CD is transversal. If CD is transversal, then you will have CD plus this thing is equal to 90. Therefore, I can say AD is parallel to BC. Okay, similarly, you have to take these two lines you take, and you can do the same way. That means I can take these two AB and CD. So this is AB, and this is CD, and I can take again CD, and I can take AD as a transversal. So this side you can take, this is AB, this is CD, this is again AD as a transversal. And then you can say these are the two angles. These are the two angles which will be supplementary angles, consecutive, and this is all supplementary angles, supplementary angles. Therefore you can say AB is parallel to CD. Okay, so here we took on the knowledge of two knowledges we have taken up, two items of knowledge. One is the sum of the angles of a triangle is 360 degree, and the supplementary angles is equal to 180 degree, and the given one, angle A, is equal to angle C, and angle B is equal to angle D, that is given. And we have proven this. Okay, so I hope this is totally clear about, and we have used one arms of this thing to make them parallel. In this case we have used AD, and in this case we have used CD. I hope this is totally clear to you. So now we are going to discuss two more important properties of quadrilateral or parallelogram. This is not a now we are talking about a parallelogram. And we have already proven in the parallelogram that not only the opposite sides are parallel, they are also equal. Now we will concentrate something which is we have already started using the properties of the diagonal. First, the diagonals of a parallelogram intersects each other, and that is within the parallelogram, within the parallelogram, or within inside writing, I can write inside the parallelogram. Okay, what's its significance? Its significance is that if I have a, say, quadrilateral like this, okay, now if you see the diagonals, this one diagonal is inside, but the other diagonal is outside. So even though it is a quadrilateral, A, B, C, D is a quadrilateral, A, B, C, D is a quadrilateral. It is not a parallelogram, because one of the diagonals, because one of the diagonals is outside the quadrilateral. Okay, so this is outside the quadrilateral, so this is not. Now first of all, it intersects, we have just said. That means it intersects within the parallelogram. So let us say, it intersects at O. So we put this one as O. Okay, so it intersects at O. So this is okay. Then we are going to prove, now we are to prove that AC and BD bisects each other. Not only intersects, but bisects each other. Means what? This bisects is very important. Bi means two. Sects means in two sections. That's a 2 units. So it definitely bisects. But this bisects has got another meaning, which means this is bisect in equal sections. which means we have to prove. Now we have to prove that bisects each other. That means we have to prove that BO is equal to BO and AO is equal to CO. This we have to prove. Now how do we prove this? This is again very, very easy. Now in order to prove that, we will pick up these two triangles or any two triangles. We can pick up this triangle and this triangle. Let us pick up this particular triangle and this triangle. Okay, if I pick up these two triangles, then I can easily prove that this already proven is equal to this. Okay, this I have proven this is equal to this. Okay, now we have taken these two triangles. We are now going to prove this one. That let us see, let us start here. We know it's a parallelogram. So AB, this side AD is equal to BC. Okay, because this is a parallelogram, or this you can also say it's a we have not yet proven the angles are 90 degrees. Okay, so this we will say is a parallelogram in which AD equal to BC, and since AD is also parallel to BC, we can say angle 1 is equal to angle 4, alternate angles, and angle 6 is equal to angle 3. Same. Alternate opposite angles, alternate opposite angles. Okay, so this is now, as soon as we say that, we have said this is point 1, this is point 2, and this is point 3. So triangle, what triangle? AOD and is congruent to triangle, triangle AOD is BOC. Okay, we have proven these two triangles are congruent. So what? Now I can write that AO is equal to CO. Why? Simplicity. And what I can write? DO is equal to BO. That is also CP. Okay, this is now known. This congruency has been proven, and these two has been proven. So the diagonal of a parallelogram intersects now within this thing has been done. Say that intersects, we have to prove that AC and BD bisects each other in equal sections. Bisects means in equal sections, and this has been proven. Now we are going to prove another theorem which says that prove a quadrilateral is a parallelogram if it's one or one of its one pair, remember, one pair of sides is equal and parallel. Okay, equal and parallel. Okay, I have used a lot of abbreviation and that should be accepted. I have quadrilateral, I have used this, parallelogram I have used, and I have also used this thing. I could have used, instead of equal, I could have used this, but I don't want it to do it. So this is equal and parallelogram. Another thing I want you to concentrate on is that it's one pair, not both the pairs. It's one pair of sides. That means what is given? So let me draw a quadrilateral first. So let us say this is the quad, this is the quadrilateral. And I will start with, as usual, I will start with, here I will start with A, B, so make some change, C, D, or but you have to use a particular order. If you are going like this, do this, okay? So you are going to go around like this, and then you can anti-clockwise direction, then you can do this. But don't do here you write A, here you write B, here you write C, here you write, don't do that, okay? Now it says one pair. So which pair I choose? I can choose any of the two pairs. Let me choose AB is given, AB is equal to CD, and also I will choose AB is parallel to CD. These two are given. These two are given. What I have to prove? To prove ABCD is a parallelogram. Okay, what does it mean? What does it mean? I have to prove AD is equal to BC and AD is parallel to BC. These I have to prove. So let me first do this. Whatever is the way you can do is to join these and make it into two triangles. Okay, what I have this side. Now I can say, let us take triangles. Let us take triangles ADC and triangle, what is it? Corresponding, let's say, CDA. Okay, I have chosen corresponding, A corresponds to C. So I have written like this, in which what is given is given AC is common, AC is equal to AC. Okay. Now now I can also write down, let me write down the angles or my notations. 1, I will go like that. 2, I go like that. 3, this is 4, this is 5, and this is 6. Okay, you can easily say, since given AB is parallel to CD, then this angle and this angle are equal. Then I can say angle 3 is equal to angle 6. Okay. And another one that is given AB equal to CD. AB is equal to CD. This is given. And this is alternate opposite angles. Why? Because I have taken advantage of here AB is parallel to CD. This is done. So these two, if you see, this is side, angle, side. So these are congruent. So congruent is triangle ADC is congruent to triangle CDA by what is it? By side angle side axiom. Okay, this is done. So once I do that, I can automatically say AD is equal to BC. So that is what I have to prove. AD is equal to BC, I have proven. And also I can take that angle 2 is equal to angle 5 by CPCT. This is also by CPCT. Okay, this is by CPCT. If angle 2 is equal to angle 5, then I can easily say that AD is parallel to BC. AD is parallel to BC. So this is proven. Prove that a quadrilateral is a parallelogram. So now in this parallelogram, I have what I have. AB is equal to CD. AB is equal to CD. These are given. And I have proven AD is equal to BC. This is proved. This is given. These two are given. And it is also given AB is parallel to CD. And also AD is parallel to BC. This is given. This is proven. Okay, this is done. So you see, at least one pair of sides, one pair, I don't have to prove both pair, equal and parallel. Then the other two automatically will fall. Okay. Okay, this is the question number 5, and this is a in a quadrilateral, in a quadrilateral. Okay, the line segments bisecting, we have discussed this bisecting number of times, bisecting angle C and angle D, okay, meet at E. Okay, prove that angle A plus angle B is equal to 2 into angle CED. Okay, first let's draw the quadrilateral. Okay, so this would be the quadrilateral. Okay, let's say this is the quadrilateral. Okay, so and we will write A because we will start from here, bottom side, and C and D. Okay, now what it says? It says that D, this thing, bisects line segment DE and bisects. Okay, the segments that bisect this and the segment that bisects this, they meet at E. So I have taken this much of time. So this is not showing that this is bisecting, but let me draw this line a little bit like this. Then it can be easily seen that it is bisecting. I said drawing first of all is essential. Okay, I have done this one now. Okay, fine, this has been done. Okay, now let's see go by numbering. So I will go 1, angle number 1, angle number 2, angle number 3, angle number 4, angle number 5, angle number 6, angle number 7. Okay, so we know. So in this notation what we have to prove? We have to prove angle 1 plus angle 2 is equal to 2 into angle 5. Okay, this is by when I am using notations. Okay, so you know this is I have to prove. Let's see how I prove this. First of all, you can see, and let's take this triangle first. Means which triangle we are going to take? This triangle which we are going to take? I am going to take the inner triangle first. Okay, what does it give me? This gives me angle 6 plus angle 5. Angle 5 is of importance to us. Angle 4 is equal to 180. That is the sum of, I will again use notation, sum of angles of a triangle. Triangle DEC. Now let us in this way, I can have angle 5 is equal to 180 minus, we'll do it together, minus angle 6 plus angle 4. This is possible directly from here to here. Now I have got 2 into 5, that I have to prove. Let me multiply this into 2. So 2 into 5 is equal to 360 minus 2 into angle 6 plus angle 4. Okay, there is no problem, only multiplication by 2 all the way. Now let us see, we have 360 here and I have to bring in angle A and angle B. So instead of here, 360, I can consider the quadrilateral. I'll write quadrilateral as this, A, B, C and D. So if you look at this quadrilateral, then I can write angle A plus angle B plus angle C plus angle D is equal to 360. Right? Okay. Now, what is angle A plus angle C plus angle D? Angle C plus angle D. So angle A plus angle B. I can write angle C as angle 3. Angle 3 as I have already drawn this, plus angle 4 plus angle 3. Sorry, it should be angle 3 anyway. And angle D I can write as angle 6 plus angle 7 is equal to 360. Okay, I have just split this angle. You will see the reason for splitting this angle. Okay, now I have here angle 6 and angle 4. So I will convert all them into angle 6 and angle 4. Let us say then angle A plus angle B plus, I need angle 4. Here is angle 4. So I will angle 4 plus angle 3 is also equal to angle 4. So plus angle 4 plus angle 6, and angle 6 is equal to angle 7 is equal to angle 6. So that is equal to angle 6. This is 360. Done? Why? Why? Because angle bisects angle C and D. The line segments bisects angle C and D because angle 4 is equal to angle 3, or you can write that other way around, and angle 6 is equal to angle 7. Given. This is given. This is given. Okay. Now from here, I'll come down to here. From here, let me start on this direction, so I don't have to bend. Okay, so in that case, I have angle A plus angle B is equal plus 2 into angle 4 plus 2 into angle 6. Okay? These two add together. This and this will add together. Angle 6 will be equal to 360. Okay. So in case of 360, I substitute it here. So substitute, let me put this one 1. This is, let me put 2 because it came later on. And let me put this one as 1. So what I can do, substitute 360 in place of 360 this one. So I can write, so 2 into angle 5 is equal to angle A plus angle B plus, this is becoming, okay, so this is equal to this into 2 into angle 4 plus angle 6, okay, minus 2 into angle 4 plus angle 6. Okay? Because that is what I am going to do in place of 360. So in case of 360, this has been put. So this and this cancels, this one and this one it cancels. Therefore, 2 into angle 5 is equal to A plus angle B. This is proved. Okay? So you got this one done. So this was given and this is the way we have done. All we have done, we have first taken this triangle and we have added summation of triangle of this. From this we took out 5 and we got this relationship and multiplied that 2 because here it is 2 into 5, so we got this relationship. We again came to the quadrilateral and we proved that if this thing is this thing, this is would be, I can add this thing, summation of angles of quadrilateral A, B, C, D. Okay, so this is what it is. In fact, it should be summation of quadrilateral, consider this thing. I can also write here summation of angles of a quadrilateral. Okay, these two you can add this one here. Okay, so this is question number is very interesting question. You have to you don't have to do much. All you have to do the summation of angles of first a triangle and then the quadrilateral and then the substitutions bisecting. Okay.